I'm excited to introduce our first special guest, Professor Wong, who will be presenting Coding to Make Music, an artful design story. Ge is a professor at Stanford University in Music, Computer Science, and the Center for Computer Research in Music and Acoustics, or CCRMA. He researches the artful design of tools, instruments, toys, games, and social experiences. Ge is the architect of the Chuck music programming language, director of the Stanford Laptop Orchestra, and the CCRMA Virtual Reality Design Lab. He's also the co-founder of Smule and designer of the Ocarina and Magic Piano apps for mobile phones. He's a 2016 Guggenheim Fellow and the author of Artful Design, Technology in Search of the Sublime, which is a photo comic book about the ethics and aesthetics of shaping technology. With that, please welcome Professor Ge Wang to present his session.
Hi everyone, how are you doing? I'm Ge Wong, and I'm going to talk about coding to make music, the story of artful design. And I'm going to introduce a bit more about who I am and what I do, and also really about how we write code to make music and use this particular kind of way of designing and way of thinking to design things like instruments, social experience, toys, and tools. So, by way of introduction, my name's Ge Wong. I'm an associate professor at Stanford University, which you see here. And I work in a place called the Center for Computer Research in Music and Acoustics. And you can get all the content for this talk and all the related resources at artful.design at that particular website. Um, and in particular, so this is Stanford campus. I work specifically in a building far off the distance under those chimneys in the back, at least during times when we're not sheltering in place. And this is Stanford Center for Computer Research in Music and Acoustics, CCRMA, and that's pronounced Karma. Uh, that's me in my office during gentler times, I would say. And I make things. And that is what I do. I make things with software. I write a lot of code, and I use that to create musical instruments, tools, toys, social experiences, all in the service of music. For example, one of the things I'm going to talk about today is the Chuck programming language, which is a programming language that's designed to generate and to program music. I'm going to give you demos of this. This is open source; it's freely available, and I often joke, only half joke, that this crashes equally well in all commodity operating systems. So whatever you're running, it's likely that Chuck will work on your system. And you can find that at chuck.stanford.edu. And I'm going to take you through the website as well a little bit later to get you started if that's something you wanted to do. Also related, I work on things like the Stanford Laptop Orchestra. And I'll talk about that more in detail later, but this is an ensemble of laptops and humans making music together as a group. I design mobile apps. And more recently, I've been running Karma's virtual reality and augmented reality design lab, which we're asking, hey, how do we think about VR and use VR as a medium for artful design? What new instruments can we craft? How might we make music together in VR? And what can this tell us about the way that we ourselves might interact or actually be, in everyday life? And so there we build a lot of things, but also we ask a lot of questions about how these new technologies actually come back to shape us and really honestly our communities and even our society uh, in turn. So design. This is the word I think that is kind of at the center of all the things I do is that I'm a designer. I design things and I make things. They have a purpose, but also I care about making them well and I care about making them with meaning. But design is all around us. And to give you a demo and to jump right into this coding with music, I want to show you a bit about the Chuck music programming language. So Chuck is is what you call a domain-specific programming language. And um, this means that it's a general purpose language you can use as any other programming language, except it's also been made to work with sound. So I'm gonna make sure that we can see this okay. So for example, I'm gonna write some Chuck code here. In this case, we're actually instantiating a sine wave oscillator. We'll call it foo, and we're going to use this symbol to connect it to the DAC, which is the output in Chuck. That's basically the speakers on my computer system. And I can say, hey, let's set the volume of foo to 0.5, and let's set foo's frequency to 440 hertz. Now let's let time pass for 2 seconds. Now, if I did that correctly, and hopefully this is not too loud, we should hear a sine wave for 2 seconds at 440 hertz. I hope that went through okay. And so with this, what we can do is we can actually copy and paste this. But we're going to change this to 220, 440, we'll leave that, and change this to 880. And what we're doing here is we're basically halving the frequency. And what that does to the pitch is it takes it down 1 octave. And by doubling the frequency, we're actually raising it by 1 octave. So these is a succession of octaves. And I'm going to do this for half a second, 1 second. And if I did this right, we should hear a sequence. And that sequence is this pitch class A in successive octaves. Now what we can do here is we make the code slightly smaller, write a bit more. We're going to put this into a loop, in fact, an infinite loop. And you do not have to indent, but you know what? It looks nicer. And in this case, we have that sequence created, but this is going to just repeat ad infinitum. Yeah, that's going to keep going unless I stop it. And here I'm going to get rid of this. And instead of hard coding these frequencies, I'm going to use a class library function to generate a random number between 30 and 1000 and set that as the frequency of the sine wave, right? Give us a little bit more room here. And if I did this every half a second, we kind of hear a new random frequency. I'm going to make this a little less loud. And you can change this kind of on the fly here. Let's change that to 200 milliseconds. And every time I hit this equal sign, that replaces the currently running program with the new version of the program. So it's a way to quickly and rapidly prototype and try new ideas. So in this case, we're hearing the same sine wave whose frequency is randomly changing every 200 milliseconds. Let's take this down to 100 milliseconds. Now, still a sine wave, but now we got kind of like the classic computer music sound, as it were. This is like the sound you might hear, old mainframe computers in science fiction movies from like 80 years ago. They make that sound when they, apparently are thinking really hard. It's a sine wave with its frequency changing randomly 10 times a second. What if we did that 100 times a second? Right, so that's 100 times. Let's go even further into kind of the granularity of time here. 1 millisecond, that's 1,000 times a second. We're going to change the frequency of the sine wave. Will it still sound like a sine wave? Well, let's listen. Not really. We started out as a sine wave. We went to kind of bleeps and bloops. It's still the sine wave at different frequencies, but here we're changing the sine wave's frequency so rapidly, at 1,000 times a second, that it no longer sounds like a sine wave. Instead, it sounds kind of like crunchy noise, right? And this is interesting because we crossed a very critical human perceptual threshold right around 20 to 30 times a second. It's kind of like the way television and movies work, right? If things are changing more rapidly or less rapidly than say 30 frames a second, you begin to see individual events. But the faster you go from that point, really beyond that point, we perceive a continuum. And here we're perceiving a kind of a stable continuum of sound, even though the sound is always changing because we're just injecting randomness into it. So that's actually how Chuck is designed to work as a tool, in that this is a tool that allows you to talk about time as you are crafting sound. And from sound, you can organize that into whatever kind of music you might want to make. And by the way, you can keep going. You can go up the direction 1 second, 1 minute, 1 hour. So every hour there'd be a new random frequency, day, there's a week. And so if I were to play that next week, basically literally a week from this point, there would be a new random frequency. In fact, you can do things like 52 weeks is what I would call a year, and every 1,000 years, there would be a new random frequency. So if we keep this running for 1,000 years, 1,000 years later, if this program's still running, then there would be a new random frequency. So within the same framework in the Chuck programming language, what you have is this mechanism that allows you to talk about time in a very precise way. And you can zoom out to talk about really long time scales, and you can zoom in to talk about very short time scales. And by the way, of course, there's this sine waves are not the only thing you can use. There's a lot more ways a lot more facilities in Chuck that you can use to actually make sound. And to this end, actually, I'm going to show you the Chuck webpage. And you can get to this at chuck.stanford.edu. And you can see here, this is where you can download it. It's like I said, it's open source. It's freely available. You can download this. There's documentation. Also, there is an online course that you can take. It's actually really popular right now. And actually, it's been popular, but it's really popular right now. I think while everyone is sheltering in place, it seems like a good time to be coding, to make something fun and possibly musical. So I recommend that you come to chuck.stanford.edu and check out all the resources. Everything is free. And also, if you want to take an online course, that is there as well. Yeah. So that's a little bit about Chuck. Now, everything else we're going to talk about in the rest of this talk actually in some way or other uses Chuck. So we're going to see kind of how Chuck is actually used. But before we do that, I'm going to show you one more thing in Chuck. And what I'm going to do here is I'm going to open an example. And in this example, what we have is some code that's already been written. And it's kind of like the code we wrote in that there's a sine wave. We're changing its volume. Here we're introducing an array, which is basically a list of elements. In this case, it's going to be integers in this list. And this is going to represent basically intervals. Here we're going to take these intervals and offset them into a musical register, a particular octave. And we're going to do so randomly, but we're going to be able to control that. And to start with, we're going to control this basically do this every 200 milliseconds. Now we're to play this. It's a kind of a low frequency, so if this is coming out of your laptop or a phone speaker, you might not hear it just yet. But if you're wearing headphones, you would hear this. I'm going to add another element into this. And you saw this blue equal sign appear. That means I've replaced this code. Now I'm going to start changing the musical registers this can actually randomly go into. Let's say between these octaves. So let's keep adding to this. Let's add a major third. And let's make it a little more. Add a perfect fifth. A little less loud. What we're going to do here is we're going to add a reverberator. The reverb, we're going to set its amount to 0.1. And once I do this, Now we hear there's a reverberation happening here. Let's make this a little faster. Add a sixth or a seventh. Make this even faster. Drop this. And it's kind of see we're basically on the fly programming this code to experiment and try out musical ideas. And in fact, you can use this way of working to craft passages in a composition. You can use this to map a musical instrument that you're designing. For example, if you want to change, you want to use your keyboard or your mouse, for example, as input device to make music, you can do that with Chuck. And you can use this on the fly, this live coding way of working to quickly experiment. Oh, hey, what is a good way to map, for example, the input, the keys, or the movement of my trackpad or mouse to sound parameters? Right. So this is a kind of a way of working. It's also a way people have used to perform, not unlike I've just done here for you, which is you're watching me write code. But that, for one, here I'm showing you the language, but there are those who actually use this as a kind of a performance approach, where watching that the code is being written in front of you is part of the performance itself, and it's part of the aesthetic of the performance. So that's a little bit about Chuck. Once again, chuck.stanford.edu is where you can find all this stuff, and all this is freely available. So please check it out if you like. And the important thing to remember about Chuck is to have fun. This is a language for experimenting. So I think you might not know, you might or might not know things about digital audio or computer music. It doesn't matter. I think this is part of the learning process if you don't know. And if you do, this becomes a tool that you can use to kind of express kind of what's in your head and to realize that. So with that said, let's return to the presentation. And let's see. Give me one moment. There it is. So that's Chuck. Now, let's look at some things that have been made with Chuck. And one of them is the Ocarina. Now, this is something I designed back in 2008 with a company I co-founded called Smule. Now, some of you might actually have used Smule products if you've used any of the Sing apps or Magic Piano or Ocarina. And the way that Ocarina works is you're literally blowing into the phone to make music. So I'm going to give you a demo here. So this is what that looks like. And I'm blowing into the microphone at the bottom of my iPhone here. And there's a Chuck program running inside the phone that's tracking how hard I'm blowing into the microphone. And the sound is simultaneously being generated. And these two elements are mixed together in Chuck to articulate the sound. So for example, this tilt controls vibrato. So this is flat, no vibrato, and as I tilt down, there's more and more vibrato. You can play little ditties with this. For example, and you can keep going with this and learn a lot of little ditties and songs to play. And so that's the instrument part of Ocarina. Now, there's another aspect of Ocarina, which I'm going to talk about, which is a social element. But before that, let's actually look at the design of the instrument itself. So as you saw when I gave the demo, there's not a lot of things happening on the screen, and that's by design. And the idea here is to make this as simple of an interface as possible. For one, the Ocarina is not a complex interface. But hopefully you can make really rich and nuanced music with it. That's kind of the design goal. So here you don't actually see an ocarina on screen, but you see the elements, the control elements, these blue buttons, and a visualization of your breath. In this case, the green lines that emanate are. Oh, yes. Uh, I need to go back to share the screen. Apologies. Um, so the design here, as you can see, is just these blue dots and these green waves that emanate that visualizes your breath. Um, and so part of the idea here is that this is meant to foreground the physical nature of this instrument, right? I mean, normally you can imagine how people use, well, how we use our phones today, usually. This is not a usual use case of a phone. The way you play Ocarina, as you saw in my demos, you hold your phone kind of like a sandwich and you blow into it, right? While you're providing different combinations of buttons to control the pitch, while even tilting up and down to make it to apply different amounts of vibrato. That's a very physical way to interact with this app, and that is also by design. In a way, it's trying to take you out of the out of the virtual screen world and into the physical world in which we live. Um, and if you look at Ocarina, this is Ocarina in gameplay mode. You can see all the different control elements, they respond to your interaction. I wanted this thing to feel organic, and the circles falling down the screen are basically telling you how to play the next note, but how you actually play that note is up to you. So this is a kind of like a Guitar Hero, but Ocarina, except it's different in the sense that the sound is not pre-recorded. The sound is being generated by Chuck on the fly, and it's up to you to make it your own. So there's a big element of open expression here. That's part of the design and part of the design goal. Um, Now, there's another dimension that I mentioned in Ocarina, and that is a social dimension. In designing Ocarina, I really wanted this thing not only to be a personal instrument, but something of a social, uh, kind of a connecting tissue. So on the globe in Ocarina, in the same app, you can listen to other people blow into their phones around the world. There's Anonymous coming from the East Coast of the United States playing O Shenandoah. From Indonesia. Here's the Legend of Zelda theme song. Who are these people? Well, we don't know. In fact, this app is not designed to tell you that. In fact, it's designed to not tell you. Right? This is meant to be an anonymous social network, and it's a one-way street. You see in the top left-hand corner of the screen, you can love this performance if you like it, but there's no way for anyone to go back and check to see how many people liked it. So it's a one-way street, and what that does is it relieves kind of this pressure of trying to be popular, have a lot of likes, and you're not going back to check how many people liked what you did because you can't do that. So all you're doing on here is simply playing music, and if you like that, knowing that no one can go back and check it, the only reason you would hit love is because you actually really loved it. So this is unlike, kind of the much of our social media today, which is really based on ways to engage you by having you go back to check on these things that make you seem more social or more popular. But in this case, it's not about that. It's about giving you a sense of connection through music and interaction and trying to remove all the extra things around that to make this feel like a honest, pure experience as much as possible. So that was the design goal of this part of Ocarina. And again, this is using Chuck to render the sound. And the way that this works is that as you're playing, your gestures are being captured, the multi-touch, the tilt of the microphone, how hard you're blowing, and these gestures are being recorded, and they're actually stored in a central database. And so when you pull this down, it's that gesture that's being rendered by Chuck in the program, the same synthesis engine that renders the instrument part of the app. So that's Ocarina, and here, if we think about, not only how do we code music, write code to make music, but I think part of it, a very important part of this design is thinking about why we might want to do that kind of thing. So that's a really good question, by the way, to for us to ask ourselves when we do anything. Like, why am I doing this? Why am I doing this hackathon? Um, the answer doesn't have to be a single answer. Part of it is like, well, I think it could be fun. That's usually a really good answer. The other might be, I want to learn something. That's a good answer, right? I want to gain experience in coding, but it's good to kind of be aware of why you're doing this. And it's like that in designing anything. So, for example, what is the underlying ethos, if you will, of the globe of Ocarina? Why was that designed? Partly it was designed because this is an app. It's also was designed as a commercial product, so it had that goal. But it was also designed aside from that this needed to be an app that needed to be sold and marketed. Uh, I would design this app for something that's also as an intrinsic experience. I wanted this app as something that could bring you calm, and so this is going back to a Mark Weiser, who's often regarded as the forerunner of ubiquitous or pervasive computing. And that's the idea that computers are, someday are going to be all everywhere in our world and invisibly helping us achieve kind of what we want to do, our purposes in daily life. I'd say computers are certainly pretty much everywhere in our world. They're pretty much not invisible at this moment. But I love this ideal that Mark Weiser articulated is that technology should create calm. This is a review from an Ocarina user in 2009. This is my peace on Earth. I'm currently deployed in Iraq, and hell on Earth is an everyday occurrence. The few nights I may have off, I'm deeply engaged in this app. The globe feature that lets you hear everybody else in the world playing is the most calming art I've ever been introduced to. It brings the entire world together without politics or war. It is the exact opposite of my life. Deployed US soldier. So, this I think speaks to something about why we design and also why we make music and make art, right? I mean, in a way, like art is not the thing that solves your problems directly. Like art, no amount of music or art is necessarily going to pluck the soldier from whatever hell they found themselves in. But I think art does something else. Acknowledges the situation you're in a way that gets you, right? In a way that helps you process what is happening to you. And I think in this age of COVID-19, this is a good time for art making for that precise reason. Not, it's not going to, this is a healthcare crisis. This is a social crisis. This is possibly this is a governance crisis, right? So it might be all of those things. And art is not going to directly solve any of those, but art is what might be what gets us through it. It's actually the thing that helps us process what is happening to us in our world. So in that sense, art is this tool to do that. So from a design point of view, I would say good design is that which enables us. It's useful. But great design, like art, tries to understand something about us while being useful at the same time. And this is really the central tenet of artful design. And that is both a way of thinking, it's kind of a design philosophy. And as I'm going to tell you, it's actually a comic book that I wrote to actually articulate this way of designing. But more on that later. Laptop Orchestra. This is something else that uses Chuck to make music. And by the way, I should say that Chuck is not the only programming language for music. There are dozens out there, from C-Sound to SuperCollider to Maxim SP to Tidal. There's any number of ways and tools out there to do this. So I highly encourage anyone interested in looking at this to try a few tools and see what really jives with you, right? And if it feels good to you, that might be your tool. But the key is to try a few and to try to make projects that you care about. Having said that, this is a project that I really cared about, and that is, really thinking about instrument design and having a laboratory and a performance space for doing instrument design. So, Laptop Orchestra, it is people, it's laptops. Each laptop station is a laptop sitting on a multi-channel audio interface that is actually sitting on an IKEA breakfast tray. Humans usually are sitting on meditation pillows and mats, and then on the left there you see a hemispherical speaker array. Now this is very critical to this type of laptop orchestra because this kind of speaker array keeps sound local to the instrument. And that's important in the sense that again it's the same physicality that I talked about with the ocarina, and that if you were to play like a violin or a ukulele or a harmonica or whatever in front of you, if you listen to someone do the same, sound doesn't come from around you necessarily from like PA systems. It comes from most directly the thing that's making the sound. So there's a physical presence that the sound that playing a physical instrument actually affords. And the laptop orchestra is trying to do that before laptops. So it's new technology, but it's trying to preserve a very old, if you will, time-honored way of physically engaging with our musical instruments. And these speakers actually were built out of something else from IKEA. These are built out of IKEA wooden salad bowls that we drilled holes into and put car speaker drivers in. Um, Here's just one of more than 200 pieces for laptop orchestra. This is a piece called Twilight. In this case, there are Chuck programs actually running on the laptops. It's not only generating the sound, but it's also dictating the mapping. And the mapping is basically the mapping from gesture through this device to the sound that's being generated. And so in that case, Chuck is used to really create the sound, but also say, hey, well, if you move in this way, how would the sound change? So it's a bit of both. Now, for something completely different, this is another instrument and piece in the laptop orchestra. This is the laptop accordion. This work? Well, as some of you might have guessed, this actually uses the front side camera on your laptop screen, and it's using a computer vision algorithm called optical flow to track how much you're opening and closing your laptop screen. And that kind of like blowing into the phone in Ocarina is articulating the sound which is being generated on the laptop. And this again is a very kind of a wacky, whimsical use of an everyday computing device. Not how you normally use a laptop physically, right? You're not sitting in front of this thing staring at a screen, and you've literally turned the device on its side, and it's on your lap, and in a different way, and you're playing it like an accordion. This is almost certainly bad for the hinge on your screen, but you know what? This is it's fun, and it's research, I suppose. Now, Chuck has also been used in designing instruments that are virtual, right? Kind of the in a way the opposite of physical instruments. And though we're not discarding this physical dimension of thinking about how we create music with instruments. So the VR lab at Stanford at Karma is a group of people. We are working to build instruments that can make music, maybe make music together, with a lot of questions we're asking about the medium of VR. Like, what does it mean to design well? What does a successful musical instrument even look like or feel like in VR, right? So, and by the way, this is part of my larger research group at Stanford, which is music computing and design, which I've led since coming to Stanford in 2007 as a professor. And so the questions we're asking in VR is what does it mean to design artfully in the medium? What are VR's artistic, philosophical, and humanistic implications? What does it mean? What new musical interactions and instruments are possible? How might we play music together? in VR, how to design novel tools for expressive VR. And I'm going to talk about Tunity in a moment, and how might we design immersive virtual environments that encourage play, stillness, and calm. So this is Marina with a VR instrument and game she's designed. This is the foot piano. So with sensor tracking on her feet, of course. She's playing the foot piano, much inspired by Tom Hanks in the movie Big. This is a two-person virtual violin. So Kyle, under the headset, is basically controlling the fingerboard. And you can see how this works. This was actually the first time we actually played this. So this captured that moment where we were just trying this thing out for the first time. And so while Kyle's controlling the pitch on a single string fingerboard in this case, I am in a way bowing the air. So I have the controller in my hand, and its location is being tracked in the space. So basically any movement translates into energy put into the system. And the more I move, the more energy there is. So I can really freely use my arms and my entire body, in fact, to express each note and to bow the air, as I said, in effect. And again, even though this is virtual, Kyle sees one side of the reality, and he sees kind of the interface that he's working with. I'm really just listening to Kyle, but I'm still very much in the physical space. And this is where the two realities kind of meet in a sense. Now, both of these projects and many other projects have been done using Tunity. And that's the tool building I had mentioned earlier. And what that is, this is Chuck for Unity, where Unity, of course, is the integrated design environment for graphics and game building that much of the world is using to make games, but also to learn about game design. So Chuck, this is a plugin for Unity that allows you to basically program graphics and all the things you get with Unity while using Chuck's timing mechanism to drive things in a very temporally precise and music-friendly way. So people can make a lot of really precisely timed musical things that are real-time, that are interactive together with graphics. So for example, this is a musical city by my PhD student, Kung-Woo Kim. This is created using Tunity. The graphics are in Unity, and the sound, as you will hear, will be done in Chuck. So the way this city works is that Kung-Woo can turn on different buildings by turning up their lights. And there's a musical process that's algorithmically generated, written in Chuck, that's working together with the graphics. So you can kind of see all the things in the music are reflected by graphical events. The Ferris wheel actually controls tempo, so you can turn that a lot and it gets faster and faster. They're planes. There are automobiles. And when the city really gets going, that's what it sounds like. And we can even go to the moon, where there are two rabbits, I believe, making rice cake. And from their concoction comes a train track. And on this train track, a train of chords are going to progress and process through the city. Yeah, I don't know about you, when I experience this puts me at ease. So you feel calm. And here comes some UFOs. They're not here to vaporize or do any harm. They're here to play music together. Isn't that nice? end of the day, things peacefully turn off, ready for the next day. So that's was built with Tunity, with Chuck for the sound and also the timing and some of the interaction, and then Unity for the graphics and some of the interaction. And Tunity kind of glues them together, right? So you can get to Tunity again from the same Chuck webpage, chuck.stanford.edu, and there's a link here for Tunity that's going to take you to this really excellent tutorial that's going to just, once you, if you know anything about Unity, this tutorial will get you up to speed in probably half an hour about how to get Chuck working with Unity and how to use it to make audiovisual and interactive things. Now, to end, I've talked a lot about coding with music, talked a lot about designing things and the things we've designed from musical instruments to VR instruments to tools, for example, like Tunity that we can use to enable certain kinds of creative endeavors. I want to step back once more, even more, to think about again this question of why, because I think at the end of the day, design, coding, programming, engineering, all of these things are about choices. And as such, I think it actually comes down to a question of what it means to design ethically. Now, I want to talk about this word ethics just for a moment because you're like, well, hey, I thought we were talking about art and coding music with Chuck. What does ethics have to do with that? Like, is this causing people harm? Oh, actually, it's the opposite. I hope in building these kinds of instruments, in this sense, it's not about avoiding how to do this and not hurt people, but rather giving people a tool that can make their lives richer, especially if they can, if they want, they can put time into it and become better at coding to make music, and then they can use this as a mode of expression, as a means of expression. So in a way, I think ethics here is not really like how do we not do evil? That's important and that's difficult. It's more like, I guess, how do you do good, which I think is a very different concept than do no evil, ethically speaking. But I think the question that in doing any of this in artful design, in coding music, right, is getting at this question, how do we want to actually live with the things we make? How do we want to live with our technologies? And so, in a way that the way I think about design, and this is an artful design way of thinking about design, is that it's actually like the Chinese character for human, 人, which you see before you in black. One leg, you might think of it as what is useful. That's design. Design is there to address an established need or aim. But the other side is aesthetics. This side is like, what are the tools to give us the affordances that we'd want to live our lives? But the other side is to ask, why we actually would do this. For what? What makes life rich and interesting? What is the way of life that we would actually want to live? And so actually in coding music, you're actually doing a bit of both. You might be learning programming. You're building tools. These are pragmatic. But there's a very just as important this aesthetic dimension to doing this. For one, you're making music. But two, it's not just what you end up with. It's the process of actually writing code to make music. In a way, it's fun. It's an intrinsically valuable experience. So this is all to say, I think whatever you do with code, with the hackathon, right there, I think there has to be an artistic leap on the part of you, the designer. The results from seeing and feeling the world at large. We as designers are less problem solvers and more artists, philosopher, engineers of useful things that understand us. Understanding in the same sense that I talked about earlier, seem to get us, that acknowledges who we are, where we are, and what's happening to us. And in this case, if one of the themes of this OpenHacks hackathon is the pandemic that we are experiencing, living through, and many of us suffering through, right? It's a time. You can make practical tools, but sometimes it's not. This being not a technological problem, maybe there's no technological solution for COVID-19, right? But there might be an artistic tool that we can build to help us understand something about what we're going through, what it's like to live in COVID 19. And that understanding, again, isn't practical, but it's something that gives us a different way of looking and feeling and living through these times. And this is all to say tomorrow's engineer, I think, has to be much more than a specialist, right? You're learning to write code, but it's not just the skill that you should be developing, right? It's the sensibility of how what kind of things you'd actually even want to build with the things you make with code and AI and algorithms and hardware and software, all of these things. So I think tomorrow's engineer has to be a kind of technological artist, a moral ethical inventor, and a system designer that can contextualize and understand how the things we build fit into society, into communities, into the world. So in higher ed, and this is, I guess, the professor in me can help but think about this as also an educational um, issue. We talk about educating. What kinds of students would we want to educate? For example, at Stanford, where we might be like, well, we don't want to educate like a I-shaped student, like the letter I, which means that this is a person who just depth charges on one particular discipline and without thinking about its broader ramifications. So then we're like, well, maybe we should have like a T-shaped student, like the capital letter T, where you have the vertical bar, which is like, well, that's it's meant to be depth, but there's breadth in the horizontal bar, and maybe that's a better combination. Well, in Artful design, there I talk about the pie-shaped student, and the pie-shaped student basically is like the letter pi. One leg represents disciplinary expertise. For example, computer science. That was how I was trained. My undergrad and graduate work were both in CS. So I really come out of this engineering and computer science discipline, but my domain is music. But for someone else, it could be public health, which is actually very, very practically relevant for at this point in our history. But it's like something that that's always important, and I suppose music is that way too. But in this pie-shaped person, the horizontal bar is what I call an aesthetic lens. It's the philosophical, artistic, moral lens that gives broader meaning and context in bridging the two legs. Um, and that means, to be a good designer, to be a good engineer, to be a good computer scientist, you also have to be something of a philosopher. You hopefully will have the sensibilities from reading history, from thinking about the social sciences, anthropology, communication studies, media studies, to understand kind of the critical tools and the ethical tools and the aesthetic tools we can bring to bear when we actually design things using our discipline. So this is to say, I think, to be honest, engineers are getting like a very mixed bag in terms of perception. Like, are they building our tools? Are they like building tools that are kind of taking down the fabric of society? Are they weaving it or are they unraveling it? In a way, I think engineers, well, we might be doing both. And that's the promise and the peril of shaping technology. But the hope is if we can not only become better coders or better builders or makers, well, we become better coders, makers, and engineers by becoming better and more perspective people. And that really asks us to go and think about things like philosophy, literature, to have an artistic sensibility, to figure out what is good, what is the kind of life we would want for ourselves, and how do we try to get there, and what does it mean to live together, right, in a community, especially when we have all kinds of disagreements among us. So all of this is actually really in the realm of the engineer, even though we don't think of them as such. It's in the realm of the engineer because it's in the realm of being a part of society. Engineers are not a separate part of society. They are, as everyone else is, a part of it. And so this is anyway. This is kind of the philosophical part, but I think this is really important in a hackathon or as it is in a course of study, because I think this is how you discover for yourself your why of why you do what you do. So, yes, I put all of this in a comic book called Artful Design Technology in Search of the Sublime. And I say it's a comic book because, well, it's a comic book. It's a 488-page comic book about everything I pretty much talked about. It has a lot of examples of coding for music, but it's meant to be more than music. It's meant to be thinking about why we design in general, as I've been talking about. But music happens to be a really good example because it's something that we all gravitate towards. All of those who can hear, who are fortunate enough to have working ears, have something that speaks to us musically. But also all of us have something that speaks to us artfully. So this book is actually kind of a way of thinking about this stuff and something that I heartily recommend to anyone who is interested in this stuff and in this philosophy, this practical philosophy of coding to with kind of a social conscience. And I'm hoping that's more and more of us. So from buildings, the design of buildings, to everyday tools, to musical instruments, to artificial intelligence with humans in the loop, there's Rebecca Febrink on the right, reminding us not to forget the human when we design machine learning and artificial intelligence systems. To design of games that is about more than entertainment, but also as a mode of expression and understanding. To social design, how do we design social systems and social tools that weave rather than unravel the fabric that we have among between us? Um, There's one final example. This is an app I helped to build 9 years ago with Smule. This is Glee Karaoke. Has since become Sing. And actually, if you download just Smule, you're actually in this. You are in this social karaoke place. Now, back in 2011, this is in the wake of the earthquake and tsunami disasters in Japan, and a woman reached out in Tokyo with a rendition of the song Lean on Me. And she invited the world to join, and over a matter of weeks, 4,000 strangers, presumably, joined her from all across the earth, as you can see. This is what it sounds like. Yeah, that's what it sounds like when there's like 1,000 people singing together. And in a way, like I'm hoping that when we experience things like this, yeah, this took a lot of technology, took a lot of design, but hopefully when things really work, what you foreground is not the technology. Like you hopefully don't notice the technology in this case. You just think about, wow, all these strangers sing together. And you think about what the song means. And you know what? Lean on Me, this is kind of not just a song for that particular time. And it's not even a song for this particular time, which I think it surely is. It seems like a song for all times. Lean on me. What a great message, just in general, for humans uh, living with one another. So, with that, this is all to say, I think the things we make end up coming back to make us. So, code with music, but think about how that changes you, and hopefully, how do you do that in a way that makes you more of, like, I don't know, the person you would want to be. And that's, at least speaking for myself, that's kind of how I go about it. And even though I teach this stuff, I'm actually also trying my best to live this stuff. And I'm figuring it out like everyone else. So in a nutshell, I think that is what I work on. And again, why is I think I'm designing, I suppose I'm designing to solve problems, but more than that, more broadly, I think I'm designing to find ways and build tools that to help us flourish. And I think that is what actually artful design is all about. Now, I'm going to end this presentation with an invitation not only to check out Artful Design at artful.design, but also during COVID-19, I'm actually hosting a weekly Zoom series called Artful Design TV, and this is no experience needed. It's freely available, and it's everyone is welcome. You can find this at artful.design anchor.fm/TV. And it's every Wednesday at 1 p.m. So please come here, register, and tune in. And we're going to basically talk artful design, coding, music with doses of history and philosophy, and with, check-in, live check-in for all the participants. So come on down to Artful Design TV and check out Artful Design, check out Chuck. And also, for those of you who are watching this live, we're going to go into a separate Q&A session. For those of you in the hackathon, the link will be sent to you, if not already, in the Slack channel for the hackathon. And with this, I want to thank all of you for listening. I want to thank you for having me. Rock on, chuck on, and be safe, be healthy, and be artful. Thank you very much.